Problem 93. A rocket is fired straight upward with an acceleration of 6 feet per second squared, 50 feet from an observer, and we want to find the rate at which the observer's angle of inclination changes when the rocket is 75 feet from the ground. So first I see we have a right triangle. So let's go through and find this third side first. So we have that a squared plus b squared equals c squared. So 50 squared plus 75 squared equals c squared. We evaluate this and we get that c is 25 radical 13. So that's the length of this third side, 25 square root of 13. Now we need to somehow get this angle involved, and we need a formula. I mean, right now this height right here is not constant. It depends on time. So I see that 6 feet per second squared is the acceleration. So let's get a formula for the height. Now we have an acceleration here. If we use our formula at acceleration, this is 1/2 acceleration times time plus v0t plus s0. The acceleration we're given is 6 feet per second squared. The initial velocity, it's not stated in the problem, but if it's fired from the ground, it wasn't moving before it was fired, we can assume the initial velocity is 0. And the initial height, again, it was fired from the ground, so its initial height is 0, which means that our height function, we plug in what we know, is 3t squared. So now we have a formula for this side of the triangle. So let's get rid of the acceleration and get a more general formula for this. Our height is 3t squared. Now I want to somehow get this angle theta involved. And I can use the two sides that were given here. I know that the tangent of theta is opposite over adjacent. Opposite is 3t squared. Adjacent is 50. And this 50 does not change because the observer isn't walking toward the rocket. He's not walking away. This distance stays 50 feet, whereas the height is changing, 3t squared. We've got our formula. Now we can take derivatives. So this tells us that secant squared theta d theta dt equals 6t over 50. Now let's multiply both sides by cosine squared to get d theta dt by itself. So we get that this is 3t over 25 times cosine squared theta. Now we want to know what the t value is, and we want to know what cosine of theta is. So first, cosine of theta. Cosine is adjacent over hypotenuse, so cosine is 50 over 25 radical 13. We can reduce this to be 2 over radical 13. And then to get the t, I want to know when the height will be equal to 75 feet. So I'm going to set 3t squared equal to 75. We can divide both sides by 3 to get t squared is 25. So then t must be 5. We can now plug these into our formula for d theta dt. So you know that the rate of change of the angle with respect to time is 3 times 5 over 25 times the cosine, which is 2 over radical 13 squared. So simplifying this, I see these 5's can reduce. So we've got 3/5 times 4 over 13, which gives us 12 over 65. So we've found the rate at which the angle of elevation changes.